Have you ever looked up and noticed how many roofs are made of triangles? In a shopping center, in a school hall, in a warehouse, in a church, in a taxi rank, even on some of the big steel bridges on the highway, you'll often see a pattern of metal or timber forming triangle after triangle after triangle. Not in every building, not in every roof, but in a lot of the wide, open spaces we use every day. Most people see those triangles and never think about them. They just become part of the background. The roof is up, it's not falling, so life goes on. But those shapes are not random. Those triangles are a big part of why these roofs can stretch so far without sagging in the middle. Why thin pieces of steel or timber can carry heavy roof sheeting, lights, ceiling boards, sometimes even solar panels and still feel safe. If you start paying attention, you'll see a pattern. Where the space is small, like in a normal room at home, you might see a simple beam or slab. But where the space is big, a hall, a factory, a supermarket, a sports arena, there's almost always some kind of triangle pattern helping to hold things up. So instead of asking, what is this type of roof called? A better question is, why do so many big roofs and long structures rely on triangles? What is it about that shape that makes it so useful? That's what this video is going to unpack, using simple examples you can try at home. To understand why triangles show up so often in roofs and bridges, it helps to forget buildings for a moment and look at something much simpler. Right here on the table are 4 straight pieces arranged into a square. Nothing complicated, just 4 sides connected at the corners. Now, watch what happens when a gentle push is applied to one corner. The square doesn't really resist. It doesn't fight back. It simply changes shape. The corners slide, the shape leans, and without anything breaking, the square quietly turns into a diamond. That movement is important. Nothing failed, but the shape could not hold its form. Now, look at the same square again, but this time with one extra piece placed diagonally from one corner to the opposite corner. Nothing else has changed. Same size, same pieces, same connections. The only difference is that a diagonal has been added, creating triangles inside the shape. Now, the same push is applied again. This time, the shape doesn't slide. It doesn't lean. It doesn't quietly rearrange itself. For it to move now, something would have to bend or break. That's the difference triangles make. A shape that can change form under pressure is unreliable. A shape that refuses to change form is predictable, and predictable behavior is exactly what you want in a roof or a bridge. When weight, wind, or movement acts on a structure, engineers don't want parts slowly shifting out of place. They want forces to be guided along clear paths and sent safely into the supports. Triangles do that naturally. They don't allow silent movement. They lock the shape. That is why triangles appear again and again in structures that must stay standing. Stopping movement is only part of why triangles are so useful. The other reason is how they deal with weight. Think about standing on 1 foot versus standing on 2 feet. When all your weight is on 1 foot, that foot works harder. Your balance feels unstable and any small movement feels risky. But when you stand on both feet, the same body weight suddenly feels more comfortable and controlled. Nothing about your weight changed. It was simply shared. That's what triangles do in roofs and bridges. When weight from a roof, a bridge deck, or even strong wind enters a structure, it doesn't arrive politely in one neat place. It spreads out, pushes down, pulls sideways, and moves through the structure. If a structure relies on one long piece to carry most of that weight, that piece has to do all the work. Over time, that leads to bending, sagging, and fatigue. Triangles change that behavior. Instead of allowing the weight to concentrate in one spot, the shape divides the load. Part of it travels along one side, part along another, and the rest is guided down into the supports. Each piece does a smaller job. That's why triangle-based structures can look surprisingly light while carrying a lot. The strength doesn't come from thickness or heaviness. It comes from how the weight is spread out. When triangles are missing, too much work can end up being done by one part of the structure. When triangles are present, the work is shared before it becomes a problem. This is not about making structures stronger in a brute force way. It's about making them smarter. Once you understand that triangles stop unwanted movement and help share weight, a lot of everyday buildings start to make more sense. Think about a small room in a house. The walls are close together, so the roof doesn't have to stretch very far. In those spaces, a simple beam or slab can often do the job without much trouble. But now think about a school hall, a warehouse, a church, or a shopping center. The space is wide. There are no walls in the middle. People want open areas, not columns everywhere. That's where the challenge starts. The roof still has weight. Wind still pushes on it. Rain still lands on it, but now the distance between the supports is much bigger. If you tried to cover that space with one thick piece of material, it would have to be enormous. It would be heavy, expensive, and difficult to support. The walls below would need to be much stronger. The foundations would need to be bigger. Everything would become more complicated. So instead of fighting the problem with size and weight, builders use shape. They arrange thin pieces of timber or steel in repeating triangle patterns. Each triangle helps the next one. Together, they create a roof that can span a large distance without needing massive material. The same idea shows up in bridges. A short bridge over a small stream might look simple, but as the distance increases and as vehicles get heavier, the structure needs help controlling movement and sharing weight. That's when triangle patterns begin to appear again. They're not there to look impressive. They're there to make long distances possible. So when triangles appear in roofs and bridges, it's usually a sign that the structure is trying to cover a big space efficiently, not by being bulky, but by being clever. When you see thin pieces of timber or steel arranged in repeating triangle patterns to hold up a roof or a bridge, that system is called a truss. That's it. No mystery. A truss is not a special material. It's not a complicated machine. It's simply a way of arranging pieces so they work together using triangles. And here's the important part. Most people live under trusses every day without ever knowing the word. Our DP house roofs, suburban houses, school halls, warehouses, factories, shopping centers, many of them are held up by trusses. So when engineers talk about trusses, they're not talking about something rare or exotic. They're talking about a very common solution to a very common problem. How do you cover a big space without filling it with walls or columns? The answer is not make everything thicker. The answer is arrange things smarter. A truss takes simple pieces and gives each one a clear job. Some pieces help control movement, some help carry weight. Together, they create a structure that feels calm and stable, even though it's made of relatively light material. That's why trusses are so popular. They save material, they save money, they make large open spaces possible, and most importantly, when they're built and maintained properly, they work quietly in the background for decades. You don't notice them because they're doing exactly what they're supposed to do. When a roof held up by triangles fails, it's easy to assume the design was bad or that the wind was unusually strong. But in many cases, the problem isn't the idea of the structure. It's what happened to it over time. Triangle-based systems work because every piece plays a role. When even one piece is removed, damaged, or weakened, the system changes. This happens more often than people realize. A member is cut to make space for a ceiling. A piece is removed to run a pipe or a cable. Extra weight is added that the structure was never designed for. Corrosion slowly eats away at a connection. Timber weakens after years of moisture exposure. Each change might seem small on its own, but Triangles rely on cooperation. They don't like missing parts. Once a piece is no longer doing its job, the weight doesn't disappear. It looks for another route. That route might not be obvious at first, but over time, the structure starts to show signs of stress. Roof sheets begin to sag. Members start to bow. Connections loosen. In severe cases, failure happens suddenly, without much warning. This is why some roof collapses seem to come out of nowhere. The structure didn't suddenly become weak. It slowly lost its ability to share the work. Triangle systems are not fragile, but they are sensitive to interference. When they're respected, they quietly carry loads for decades. When they're misunderstood or altered carelessly, problems begin. The next time you walk into a shopping center, a school hall, a warehouse, or drive past a bridge, take a moment to look up. Look at how the roof structure is arranged. Look for the repeating shapes. Look for the triangles quietly doing their work. Those shapes are not there by accident. They are not decoration. They are not over-design. They are the reason wide spaces can exist without walls in the middle. They are the reason light materials can carry heavy loads. They are the reason many structures feel calm and solid even during wind and rain. It's also important to remember what this doesn't mean. Seeing triangles doesn't automatically mean something is safe forever, and not seeing them doesn't automatically mean something is dangerous. Context matters, design matters, maintenance matters. But understanding the role of shape helps replace mystery with clarity. Hi everyone, the South African engineer here. If this explanation was useful, please like the video, subscribe, and turn on your notifications. Every subscription is a brick used to build the Engineering Explained house. Let's build this house together. Thank you for watching.